Cimatron E's powerful NC application is equipped with full CAD capabilities that include powerful surface mending capabilities like capping burn areas, fixing geometry, and creating contours and surfaces. ENC is fully associative to the model and effectively supports engineering changes, comparing surfaces before and after the change. The application involves 3 simple steps that define the NC process. Also available is a one-button definition of the complete machining process, used mainly for a family of parts. Dedicated features for deep cavity machining and for high-speed milling are reviewed later in this segment. Following are the 3 steps in the NC process. Step 1. Define a toolpath with start point, origin, and safety Z. Step 2. Define the stock by bounding box of the part surfaces. This stage also supports shaped stock. The stock is used to prevent collision of the tool and holder and to control tool load. Step 3. Create the NC procedures. The example shown here is rough machining of the entire part. This option allows the system to optimize the machining strategy. Alternatively, it can be controlled by the user. The next stage is simulating the resulting toolpath. Here, simulator and verifier display the material removal process and the resulting part. Local modifications, including trim, move, project, and delete, are applied. NC programming continues with the following steps. Re-rough. The re-rough procedure reduces the steps created by the rough operation and leaves a constant thickness layer for semi-finish and finish operations. Re-rough automatically removes residual stock, otherwise inaccessible by previous tools. It calculates efficient and safe tool paths based on the knowledge of the actual remaining stock to be used for these options. Optimized machining strategies, efficient air connections and plunges, adaptive approach and retract types, and constant chip load control. At all times, re-rough avoids collision of the tool and holder. Finish. At this stage in the process, 3-axis finishing provides high-quality machining strategies based on the model's shape. Geometric analysis of the part and the tool is performed, and a machining strategy is selected. The result is efficient tool paths and high surface quality for vertical and horizontal machining areas. Verifier. This analysis tool marks the progress of the machining process and compares the resulting stock to the desired part. These tools help the user view the surface's finish quality and determine what areas require remachining with smaller tools. Remachine operations. This stage in the process includes cleanup that detects all the locations where previous tools could not reach and creates a finish operation in unmachined areas. If required, the application automatically applies re-roughing and detects horizontal and vertical areas while it assigns the appropriate finish and re-rough machining. The pencil feature removes scalp along internal sharp corners of the part in order to generate high surface quality and avoid manual polishing of these areas. The user has the option to machine up only or down only to optimize cutting conditions, or mixed directions to minimize machining time. Post-processor and setup sheets enable the creation of dedicated G-code files for various machines. ENC supports subroutines for 2.5-axis milling, as well as cutter compensation, linear, circular, and spline interpolation. The application supports all CNC controllers available on the market today. The user has the option to work externally without opening the application, making the process results in output setup information that includes toolpath origin, cutters used, and a parameter table for the shop floor operator. Cimatron E's Process Manager efficiently manages your toolpaths and clearly identifies the status of toolpaths and procedures. The application controls the display of NC procedures, including colors and line font. Other advanced features in the NC operation include rapid manufacturing process planning, identification of the scope of changes that enables automatic update, and automatic update of stock removal throughout the entire process. As with any Windows-based tree, you can cut, copy, and paste all of the items. The NC Guide allows immediate access to specific functions and parameters. It helps novice users perform the right operations in the correct order to dramatically improve programming efficiency. A step-by-step wizard mode guides the user through procedure implementation. The NC Assistant provides online help according to the selected function and option. Cimatron ENC's high-speed milling function includes routines for smooth cutting conditions at maximum feed rate and constant tool load. It features round corners of tool movements, trochoidal milling, and round rapid capabilities. ENC offers smart algorithms to automatically adapt the machining strategies to part geometry. This function enhances the entire machining process. Optimized cutting strategies include stock spiral, in-out, out-in, and adaptive approach and retract according to the specific stock. Adaptive plunge strategy is achieved by automatically selecting the plunge option, either tangent helical or Z, according to part geometry and actual stock remaining. Adaptive feed control reduces feed depending on the material removed or knowledge of remaining stock to maintain constant chip load. Air motion optimization optimizes clearance and is incremental according to actual remaining stock. The application uses various machining strategies for vertical and horizontal areas. Flexible finish machining strategies enable high surface quality in any part geometry. Users can employ various criteria to automatically select all entities that meet a certain profile. To save programming time for similar parts, you can save a toolpath to a template. Cimatron ENC offers an integrated environment for CAD and CAM. Electrode burn areas are easily capped using a contouring option that automatically locates the outer boundary of the selected faces. The bounded face is then created using new technologies that allow for optimum tangency to adjacent faces and very high success rates. The load template, the user-defined one-button NC technology, contains milling strategies, tools, parameters, and geometry selection. The rerun feature allows any procedure to be recalculated according to any change in cutters, geometry, or machining strategies. This option enables an efficient NC programming process. The cutter library attaches milling technology information to various cutters. This feature focuses on holder definition to justify 5-axis tilting, and cutting conditions may be applied from the tool to the procedure. The user enters the recommended manufacturer's cutting conditions for feed rate, downstep, and sidestep, including plunge and ramp restrictions. 5-axis milling is tailored to meet toolmakers' needs. Here, automatic 5-axis tilting uses small, short tools with conic shank and large holders to machine deep cavities with small details and small corner radii, enabling milling instead of electrodes. 5-axis positioning reduces the number of setups in the process. This is supported by 5-axis material removal simulation and 5-axis machine simulation, a real-life machine environment with full gouge detection. The application also includes 5-axis trimming of edges for vacuum-forming products. If required, the user can modify toolpath motions directly without the need for rerun to recalculate. Here, pencil machining of the small boss in the center is cut. The application identifies hole shapes, assigns suitable cutters, and defines drill properties, including the XY location of each hole and the drilling process. Auto search is also provided and offers close value alternatives for missing tools. Five-axis positioning offers 5-axis connections that give the user complete, reliable graphic control. Further, the application's 5-axis connections work with various clearance types.